below is the Boltzmann distribution with kinetic energy on the x-axis. For nitrogen at 300 Kelvin, please add lines or curves to the plot for the following. N2 at 600 Kelvin, B, O2 at 900 Kelvin. Please also point to the most probable kinetic energy and the average kinetic energy for nitrogen gas at 300 Kelvin. We've talked about the average kinetic energy, and let's start by just dealing with this 300 Kelvin. And I'm glad I have 3 different colors of pens here for the other ones. So the average kinetic energy for nitrogen at 300 Kelvin is going to be somewhere just over the peak. And where you draw it exactly is up to you. But we're going to write KE average there. And something I didn't mention, but hopefully this makes sense, the most probable kinetic energy is the kinetic energy with the highest fraction. So the most probable is going to be the peak, P-E-A-K. Peak is the most probable kinetic energy. And now, are there any questions about that before I do the next parts? Now we're going to do nitrogen at 600 Kelvin, oxygen at 900 Kelvin, and I'll just make this point. So because this is kinetic energy, all gases have the same average kinetic energy. All gases have the same average kinetic energy and the same distribution of kinetic energy. At the same temperature. So it actually doesn't matter whether I'm saying nitrogen at 600 or oxygen at 600. As long as kinetic energy is on the x-axis, the curves will be the same. And what we should try and do, although I'm not too worried about it, I do note that we do have numbers here. And I'll do my best. I do know that as temperature doubles from 300 to 600 Kelvin, my average kinetic energy should double. So I don't exactly know what the number is, but at 300 it's there, at 600 it should be about there. Let's see if I can draw this. And somewhere right around there, I'm not sure that actually worked out. But that's going to be my one for 600 Kelvin. And my one for 900 Kelvin should be somewhere around there. And here's the thing I'm looking for in your drawings. So one, does the distribution shift to higher kinetic energies? And two, well, I guess maybe there's 3. So all of these have to start at 0, 0 at the origin. So that's a side note. So start at origin. I guess the third thing would be that the area under each curve is approximately the same. area under each curve is approximately the same. And they don't have to be exact, but I also don't want them to be super different. Okay. And again, this is for kinetic energy, and kinetic energy is different at different temperatures for all gases. Okay.